Hey, student, how are you? Welcome to our session on permutations and combinations. Let's take a look. Let's start with these four letters. How many different ordered arrangements can you make choosing two letters at a time? Well, we could do A, B, A, C, A, D, B, A, B, C, B, D, C, A, C, B, C, D, or D, A, D, B, D, C. These are all the different orders that we can create with these four letters, choosing two at a time. Permutations are when order matters. We have 12 permutations, with four letters choosing two at a time. Combinations are when order doesn't matter. So if we take a look at AB and BA, they're the same combination. A and B are together. So we'll only count AB one time. And we'll do the same thing with the others. AC and CA, we just need one combination where A and C are together. We can get rid of DA because we already have AD, BC, so we can get rid of CB, BD, we can get rid of DB, and the last two. So we've got 6 combinations, 4 letters choosing 2 at a time where order doesn't matter. Let's focus on permutations. There are 10 people running a race, and they can win either first, second, or third place, so order matters. How many different arrangements can be made with these 10 racers, choosing 3 at a time? So we've got 3 positions, first, second, and third. There are 10 people that could win first place. Once somebody wins first place, there are only 9 racers left to win second place, and then 8 racers left to win third place. So we can multiply these together and we get a total of 720 permutations. Let's take a look at another example. You have to arrange 5 people to sit in 5 chairs where the order matters. How many different arrangements are possible? So using the same idea, we've got 5 seats. First seat, there are 5 people to choose from. We've chosen one person to sit in that first chair, so there are only 4 people left for the second position. 3 people for the third chair, 2 people for the fourth chair, and 1 person left for the fifth chair. So we can multiply these together, 5 times 4 times 3 times 2 times 1. And this is called 5 factorial. We get 120 different arrangements. So a factorial is the exclamation point that you saw. And this tells us that we want to multiply all positive whole numbers from a given starting number all the way down to 1. For example, 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we get 3,628,800. And 0 factorial is equal to 1. Permutations formula. We have n choose r. N is the total number of items, and r is the number that we're choosing at the time. Factorial is what we just saw. So permutations n factorial divided by n minus r factorial. Let's use the permutations formula to do the example with our letters. We had 4 letters and we're choosing 2 at a time. So n is 4 and r we're choosing 2 at a time. We get 4 factorial on the top and then 4 minus 2 factorial in the denominator. And this is equal to 4 times 3 times 2 times 1 over 4 minus 2 is 2. So we get 2 factorial, which is 2 times 1. And then we can cancel 2 times 1 in the top with 2 times 1 in the bottom. And we are left with 4 times 3, which is 12 permutations. Combinations formula. Combinations is when order doesn't matter. So the combinations formula is very similar to the permutations formula, except that we have r factorial added to the denominator. Let's take a look at our letters example using our combinations formula. We have 4 letters, and we're choosing 2 at a time where order doesn't matter. So n is 4 and r is 2. We'll substitute 4 and 2, n and r, into our formula, and we'll multiply our factorials. 4 minus 2 is 2, so we get 2 factorial times another 2 factorial. We can cancel 2 times 1 in the top with 2 times 1 in the bottom. We're still left with 2 times 1. And we get 12 over 2, and we do get 6 combinations. Let's take a look at another example with our combinations formula. A company has 12 employees, and the boss wants to send 3 of the employees to a conference. So order doesn't matter. There's no hierarchy of the employees. They're just all going as a group to this conference. So this is combinations. How many different combinations of 3 employees out of 12 are possible? So we do have 12 total employees. So 12 is n, and we're choosing 3 at a time. So r is 3. We'll fill in our formula. We'll subtract and multiply. We can cancel 9 times 8 times 7 times 6 with 9 times 8 times 7 in the bottom. And we are left with 1,320 divided by 6 is 220 different combinations of 12 employees choosing 3 at a time where order doesn't matter. Let's do another type of combinatorics problem. How many different ways can you arrange the letters in the word Alabama? So we'll do total letters, factorial in the top, divided by the letters that repeat, factorial in the bottom. So we see that Alabama has 7 letters, so we get 7 factorial over. There are 4 A's that repeat, so divided by 4 factorial. We don't want to double count ALA and then ALA again with a different A. They're all A's. And we'll multiply and cancel, and we are left with 210 different arrangements. Let's do another similar one. How many different ways can you arrange the letters in the word Mississippi? So once again, we'll do total letters, factorial in the top, divided by the letters that repeat. And we have several letters that repeat. We have 4 I's, 4 S's, and 2 P's. So in the denominator, we have 4 factorial times 2 factorial. And we'll multiply out our factorials. We'll cancel and multiply. And we get 34,650 different arrangements of the letters in the word Mississippi. Let's do another one. You are a teacher, and you need to line up the following students, Gary, Quentin, Elsa, and Liam, in a single file line to walk down the hall to music class. However, Quentin needs to be next to Gary in order for those students to behave and walk quietly down the hall. How many ways can you arrange these students? So we'll treat Quentin and Gary as a single student. So Quentin and Gary can be the 2 students in the front, and then Elsa and Liam. Quentin and Gary, and then Leah, and then Elsa. And then we can do Elsa, and then Quentin and Gary in the middle, or Quentin and Gary at the end. Then we could change the order to Gary and then Quentin and do the same list. So let's take a look at how to work this out algebraically. We can count the number of arrangements where Quentin and Gary are treated as a single student. So in the first position, we've got 3 students to choose from because Quentin and Gary are considered one student. And then we've got 2 students for the next position and then 1 student for the last position. But then we can switch the order of Quentin and Gary to Gary and Quentin and do the same thing. So 3, 2, 1. So we've got 6 times 2 or 12 different arrangements. And let's do one more. How many numbers between 1 and 100 inclusive are divisible by both 5 or 8? Find how many numbers are divisible by 5. So 100 divided by 5, we get 20 numbers from 1 to 100 that are divisible by 5. Then we'll find how many numbers are divisible by 8, doing the same thing. 100 divided by 8, we get 12.5. So 12 numbers are divisible by 8 from 1 to 100. And we can add those together. We get 32 numbers are divisible by 5 or 8. However, we have double counted the numbers that are divisible by both 5 and 8. We counted those numbers divisible by 5 and then counted them again divisible by 8. So we need to find how many numbers are divisible by both 5 and 8, which is the same thing as being divisible by 40. So 100 divided by 40, we see there are two numbers divisible by 40 between 1 and 100. So 32 minus 2 is 30. 30 numbers between 1 and 100 are divisible by 5 or 8. And that concludes permutations and combinations. Thanks so much for joining our session, and I'll see you next time.